Hey guys, today we're doing lesson 413, and what we're doing today is we're using the side and side angle side to determine whether triangles are similar, and then we're also going to apply each one of those to solve real world situations. All right, let's take a look at our warm-up. The first question's wanting to know what are the congruent angles, and they want us to list each pair. So as you know, anytime you see those arrows, you need to think to yourself, I'm talking about parallel lines. So you can extend that if you need to. I know some of you don't, okay? But what you want to do is you want to take a look at which ones would be alternate interior and or alternate exterior, depending on how that would work out, okay? So you want to pay close attention to that, okay? And because of this being transversal that goes through here and this being your parallel lines, okay, you want to pay close attention to that because you know A and D are going to be congruent because of the transversal. So angle A would be congruent to angle D, and angle C would be congruent to angle E. All right, so now my similarity statement would be triangle ABE. Now remember, it doesn't really matter the first one is similar to triangle, but this one matters. What went with angle A? Angle D. So D is going to come first, and then of course B is the same. It'll be in the middle. And then what went with angle E was angle C. All right. Now it's telling me if AB is 8, that's this right here, and BD is 20, that's this right here, and then BC is 25, that's this one right here, find BE. Well, here's BE. So they're wanting me to find that. Now, you got to remember this triangle here is kind of like flipped up, okay? But you want to take a look at what is my constant, okay? My constant is going to be these two here. It doesn't necessarily matter which one goes on top. You just need to be sure that when you line it up, that you line it up the same, okay? So what I'm going to do is I'm going to put 8 over 20. And I'm going to put that equal to then x, which is my question mark, over 25. Cross multiply, you get 20x equals 8 times 25 is going to be 200. Divide by 20, and x equals 10. Or I guess that's actually BE would equal 10. Should have put BE there. All right. Although it doesn't matter. What matters is that you set it up correctly. That's what matters. Remember, how you set it up on the left determines how you set it up on the right in order for it to be a true proportion. Okay, now for part 2, we're going to solve the proportions. So we have 6 over 8 is equal to 21 over x. I'm going to cross multiply, and that's going to give me 168 equals 6x. Divide by 6, and x equals 28. Okay? Now, when you do this next one, don't panic, okay? It's just going to be doing distributive, that's all. In fact, I'm going to scoot over here a little bit, but I'm going to do x plus 2 over 6 equals 2x minus 1 over 15. Now, when you cross multiply, you just think of that as being in parentheses and you do distributive property. That's all you're doing. So 6 times 2x minus 1 is going to be 12x minus 6 equals 15 times x plus 2 is 15x plus 30. Then you just work it just like you do a regular equation. That's going to give me negative 6 equals 3x plus 30. Subtract 30. And that gives me negative 36 equals 3x. Divide both sides by 3, and x equals negative 12. Okay, now, what we're talking about today is side-side-side similarity theorem. If the corresponding sides of two triangles are proportional, then the two triangles are similar. So here they have it set up. If AB over YZ equals BC over ZX equals AC over XY. So they're just setting up corresponding sides. That's all they're doing. But if they're all three sides are proportional, then these two triangles are going to be similar. Now, when we go to look at example 1 and it says determine if any of the triangles below are similar, you want to take a look at, and it's kind of difficult, I know, because some of them are turned different ways, but this is the way I'm going to look at this. I'm going to look at the base, first of all, because I know that that's pretty obvious, which is 24 and 16 and 36, because I can tell the base of each triangle. Not 16, 18. Sorry about that. That's the base of each of my triangles, okay? So then I'm going to take a look at, well, how do I know which one would be corresponding among all of these? So what I'm going to do is I'm going to take a look at, the largest side, which is the base every single time. That's why I picked that. And then I'm going to set that up with the smallest side, okay? So I'm going to set up 24 with 20. And I'm going to put 18 with 15, and I'm going to put 36 with 30, okay? And I'm just going to set it up that way, because that way I'm setting up the largest side, which is the base, with the smallest side on each of the triangles, okay? So I'm going to set that up as, and I'm just going to put the smaller one on top, 20 over 24, and then 15 over 18, and then 30 over 36. Now, of course, you have to simplify those fractions. You can't leave them like that, okay? So what you could divide both of these by would be 4, and that's going to give you 5 over 6. And then you can divide both of these by 3, and that's going to give you 5 over 6. And then you can divide both of these by 6, and that's going to give you 5 over 6. So each time that we did that with each of those triangles, we got the same ratio, okay? So that tells me when I set up the proportional sides, are they going to be the same proportion? And they are. So my answer to that is yes, these triangles are similar. It doesn't tell me I need to write the similarity statement. If it did, I would certainly need to write that. But it doesn't ask me. It just asks me if they are. All right, let's take a look at example 2. Now, when we take a look at this question, it is asking me to find x and y such that triangle ABC, ABC is similar to DEF. So this helps a lot because it's giving me that similarity statement that lets me know that this triangle could be turned just a little, so that it lets me know that this side over here, AB, is going to correspond with DE. And you can tell that because of the letters they give you in the similarity statement. So that kind of helps you. The other one didn't have that, so you're kind of maybe not real sure what to do there. But this one's going to be really obvious how to set up the corresponding sides. And they want us to find X and Y. So the first thing I'm going to look for is, are there corresponding sides where they both have a measure? Because if there is, that's going to be my constant. And I can see here 9 and 6, those are corresponding. So that's definitely going to be my constant. Okay, and then I'm going to set that up. And let's see, I'll go start with X. Okay, so I have 4x minus 1, and that's going to correspond to 10. So since 9 is on top, 4x minus 1 goes on top over 10. And then all I have to do there is cross multiply. Just think of it as distributive. Don't panic. 6 times 4x would be 24x minus 6 equals 90. I'm going to add 6. And that gives me 24x equals 96. Divide by 24, and x equals 4. Okay, again, I'm going to use my constant of 9 over 6. This time I will be solving for y. So I take a look at that. I can see the y here. It's going to correspond with 18. Sometimes people like to connect them, and if you like to do that, that's fine with me. Okay, if it kind of helps you keep it lined up. All right, so because 9 is on top, 18 will be on top over y. And then you just cross multiply. 6 times 18 is 108 equals 9y. Divide both sides by 9, and y equals 12. Okay, pretty good stuff right there. Okay, now this time we're talking about side angle side for similar triangles. And this says if two sides in one triangle are proportional to two sides in another triangle and the included angle in both are congruent, then the two triangles are similar. So just remember, the included angle means the angle that comes right between those two sides, okay? So this is telling me that AB, and XY, okay, is equal to AC and XZ. And then it says angle A, that's that one, is congruent to angle X. Okay, so it did. They said first AB and XY, that's this one, and then AC and XZ. So that gives me side, angle, side, side, angle, side. That's what they're talking about, okay? Then I can say that those two triangles are similar to one another, okay? Similar to one another. Okay, so for example 3, it wants to know, are the two triangles similar and how do you know? So just take a moment, just be careful here. I realize that this one is flipped, okay? But it is a right triangle, so that helps a lot, okay? Kind of helps keep you straight. But you can tell that this smaller leg here, the 15 and the 10, okay? Those are corresponding sides. So then that way you want to be sure that you set it up correctly, okay? Now, there's two different ways that you could set this up. I'm going to go ahead and just do from this side to this side, okay? And you can actually set it up like this. This time, I'm just checking to see, are they proportional, okay? Does it work out that way? So I'm going to put 15 over 10 is equal to 36 over 24. Okay, and just like I did in the lesson in 4.10, cross multiply going down and see if you get the same thing. So 36 times 10 is 360, okay? And then 15 times 24 is also 360. Now, I could have also done it a little bit different way, okay? I could have done it like I did on the front, okay, which it will still work out that way. This all has to do with how I showed you guys. As long as what you do on the left, you also do on the right, then you're able to see, is it a true proportion, okay, which means I can do that same thing here. What I did on the front was I did the large over, or did I do small? Okay, I did small over large, so I'm just going to do that again just to show you guys. I'm going to do small over large, 15 over 36 in the same triangle, small over large in the same triangle, 10 over 24. And then I cross multiply, 36 times 10 is 360, and 15 times 24 is also 360, okay? And this is a perfect example of how I told you guys that one person might set it up this way and one person might set it up this way, but guess what? You both get the same answer, because as long as the way you set it up on the left, you do the same thing when you set it up on the right, then it is a true proportion. So there's more than one way to do this. You just got to pause a moment, don't rush, and think about it, okay? Now, for example, 4, it's asking me, are there any similar triangles? How do you know? Okay, so let's take a look at this here. We actually have a smaller triangle here inside of a really big triangle here. So there's 2 different ways you could look at that. You could look at 9 and 12, okay, being the 2 sides of the small one. And then you're going to have to combine these 2 to be the sides of the larger one. So this over here would be 17, and this over here would be 12, okay? So you have 9 and 12 of the small triangle, and then you have 12 and 17 of the larger triangle, okay? So I don't want to freak people out or anything, but you do have a smaller one inside of the larger one, okay? Now, it doesn't necessarily matter. It doesn't necessarily, my goodness, you guys, hang on a minute, let me get a drink of water. Okay, it doesn't necessarily matter how you set it up. You could do the small and large of the same triangle, the small and large of the other triangle, which, you know, I could go for that because that's the way I did the first example on the other page. I also did it right up here in this other one here. So you're going to take the small and the large of the same triangle. So I'm going to do the small triangle first, small and large. That means if I did small and large of same triangle here, I'm going to do small and large of same triangle here, which would be 12 and 17. Now, cross multiply. 144 and 9 times 17. Let me get my calculator for that one. Is 153. Now, did I get the same? No, I did not. So the answer to this is no, they are not, okay? Oh, I didn't put yes up here. Oh, I didn't put yes up here, and I needed to do that because when you get the same proportion, you're going to write yes. I did not get the same proportion there, so I'm going to put no, okay? Now, it tells me from example 4, what should BC equal in order for these 2 triangles to be equal? So that's interesting because then you have to take a look at, you know, well, what would it have to be? So what you can do is, and they want to know BC. So for BC, I can make that be X, okay? Not 5, X. So BC is the problem here. What would it need to be? Well, when I solve for X, I'll know. So then I'm going to take a look at the 9 and the 3, and then the 12 and the X. And I'm going to set it up just like that. 9 over 3 equals 12 over X. And then cross multiply to get 36. 9X. Divide by 9. And X equals 4. So that tells me that if BC was 4, then I would not have gotten the wrong thing here. I would have gotten the right answer. It would have turned out the same. So interesting. Very cool lesson.